So, hello everyone, and welcome to yet another problem from Gigs for Gigs. This problem is BST to greater sum tree. Here, we are given a root of a binary search tree with a unique node values, and we wanted to transform it into a greater sum tree, where each node contains a sum of all nodes greater than that node. So, let's take an example of this tree. Let's take this tree and it is transformed within this tree. So you see that every node, let's say 15, is sum of 29, 40, and 35. So which is 104. And likewise, well, one may ask what would be the value of maximum node, which is 40, because no other node is maximum than 40. Then it would be transformed to 0. So 35, it has only one node of 40, so 40. And you got the drill. Same for this. So 6 has only one greater node as 7, so it would be 7 coming up here, and instead of 7 we would have 0. And that's it, that's it. So the problem is very simple. The idea here for the problem is we wanted to get the greater numbers from current node, sum them up, and store it, and then proceed to next smaller nodes. So this would be the way we would be approaching it. Why we are taking the greater numbers first, you may ask. You can start with the smaller numbers as well, but it would logically it's saying that taking greater numbers first would give us a cumulative sum. So if I'm taking a greater number first, that max number, then second max plus is would equal to the value next for third max. uh, and so on. This value would be then stored up for fourth max, and so on. So this is how we are going to approach. We wanted to first of all go ahead and take the greater number, and if I'm completely starting new for a tree, I wanted to get the greatest number from till the right. Then I wanted to go ahead and store it. For storing it, I need to come to the current node and then proceed into next smaller nodes. And smaller nodes, you know that by now that we would get onto the left because it's a binary search tree, right? Cool. So with that into our mind, let's begin with our code. And again, we would also need sum to store the current running sum, right? So what I'll do here is, instead of creating a global variable, which is not recommended within interviews and within a general coding practice, I would go ahead and use a helper method, which would accept the root and a new int with initial value of 0. Don't worry, that would be perfectly static. It would not give anything. And this new array which I'm creating, I would name it as sum, which would be responsible to store sum. So first of all, I'll check if root is equal to null. Then I would take a short exit. I don't want it to do anything. And now coming back to our algorithm, I wanted to proceed first to right. So I'll go ahead, go to right, go to the right, and I'll go to the right with a helper telling me to go to right with the current sum. Now it says me, and then get the greater number and store it. Okay, I'll store the number store the number. First of all, I'll get the current backup root.data, because when I would store this, I would be overwriting that sum of 0. And once I'm storing this sum, I wanted to update this one. So sum of 0 is equal to current plus equal to current. So cumulative sum. This is required for any next person asking me sum. So I don't need to go ahead and check who was my previous. The moment I've updated this, I'm going to store this. That's it. So I'm done with storing this. And next, proceed to the next smaller nodes. Smaller nodes, as you know, it's on the left. So go to left. And how would I go to left? I'll helper root.left with sum. And that's it. That's pretty much it. No rocket science, nothing. Let's compile this for any of the test compiler errors. Okay, it compiles very well. No compiler errors. Let's submit this for rest of the test cases. But do hold your breath, because this has one issue with it. Although it might seem everything is good on the surface level, it is submitted, but it might hit a area where we would go beyond the current limit or the integer limit. So now we are adding current to our sum. It would happen that sum would eventually reach towards integer the maximum value, and the moment it crosses that, it would go ahead and it would cycle back to integer dot minimum value. So this is a bug, or this is a consideration or an assumption we can make while proposing this code. So the problem already addresses it or not, I'm not sure, but you should do this in your interview. That was all about it. For more BST content, click the video on your right, and I'll see you in the next one.